Let's say that our warehouse management system has some custom hardware to monitor the business. How the data is being sent into the application or what the payload contains is irrelevant. We can just assume that the structure of the data is simple, and when it arrives to the application, it's a large stream of bytes. We'd like to validate the payload. To do this, we are going to look at the last 128 bytes. If one of these bytes has the value 1, the validation has failed. Of course, a real signature validator would be a little bit more complex, but we're focusing on the span. Let's introduce a payload validator and add a method that accepts a span of byte. To grab the last 128 bytes, we can do that by using the range syntax. Don't forget the hat. If you do, it will create a slice starting from the 128th byte until the end. That may result in a much larger slice than you'd like. So far, we've grabbed a slice of the span, and no extra allocations has been necessary. We can introduce a simple check that iterates through this span to validate the data. Again, in reality, this validation would be a little bit more complex. Let's return true at the end of the method. One potential issue that I'd like to highlight is that since we are working with the span, which is just a pointer to an array, does that mean this method can change the original array? Let's go ahead and grab one of the bytes in this span. Let's then change the value and head over to the program where we can create a byte array that will now be passed into this method. If we run this with the debugger attached, we can see that it changed the value in the array when we're inside the validate method. If we continue the execution, we can see that after we've exited this method, the original array also changed. While this makes sense, this can be problematic. We might not want that anyone tampers with the data when we pass this around. While we've been memory efficient by avoiding a copy of the array when slicing that, there's still a bit of improvements to be made. We can prevent anyone from changing the content of the span. We could change it to be a read-only span of t. And there's an implicit conversion to read-only span as well, so you don't have to change anything where this is used. You can pass an array of bytes into this method, which now promises that it won't change anything on the array. It not only promises that it won't change anything, it couldn't if it so wanted to. As a side note, if the read-only span contains reference types, and that reference type has properties that are not immutable, the data would be changeable. A read-only span only makes the operations on the array read-only. It doesn't mean the elements within the array was automatically turned immutable. As mentioned, the span lives on the stack. It cannot be used as a field in your class, and you cannot use it inside an asynchronous method. Most of the time, this is completely fine. In the situations where this causes a problem for you, you can use another class that was built to complement the span of t, known as memory of t. This isn't going to be as performant as only relying on the span. If you end up in a situation where the span isn't enough, and you have to introduce memory of t, you should really consult the guidelines to make sure that you do not run into any performance problems. Using span together with the range syntax makes working with different types of arrays much easier, no matter what it contains.